Hello, this is part 3 of our hand trace table that I want to talk to you about with it before we get into the nesting of the for loop with this thing. Just to give you a heads up on what's going on with this table that we did the flow chart. I did the flow chart with you so you can see that this is where you have right now for just a simple flow chart. What we kind of have is what I've done is I kind of coded this with our 3 library files that we have. Gave it some constants of rows and columns in here, because here's what we do know is that we do have is a 4 columns and several rows that we want to set equal to. This first set of code from here to here is what I am printing as the 1, which are these exponential of 1, 2, 3, and 4. And then I'm setting the width of this particular row is to set W10, meaning 10 is the space between here, aligning to the right. And it's going to end, this end is this 1, and it's going to increment. Okay, now I just want to give you a heads up is that this n, this last n right here is going to be 5. But when you plug 5 less than or equal to 4 here, it's going to be false. So this entire block of code will never be executed. Alright, coming down here to the second round is 1 to 4 again, and it's going to output the x with a little space after it. So it's going to look like an x with an is the base with this. So this is the base and this is the exponent with this thing. Again, this n is going to end with what? 5, but it will fall out in the loop. 5 less than or equal to 4 will be false. Okay, so this is what happens with it. Down here in this loop that I have here for the body, from here to here, is that I'm going to start out with the x is equal to 1. 1 is less than or equal to x max. If you recall, x max is 10 with this, alright, which is true. It's going to nest in, go in, okay, allowed you to go in. N now is 1, and the x n max, this is n max, okay, is 4. Alright, so you're going to do an exponent of 1, and you're going to set this exponent using the POW. I'm going to drag this over so you get everything on here. So here's your POW of your base. This is why you need the C math library file on top with this thing. So your POW, this is 1 raised to the n is 1. 1 raised to 1 is 1. Next is x is 1 raised to the n is 2. So it's still 1. 1 raised to 3 is still 1. N raised to the 4, still 1. Now when this n becomes n5, which it will become n5, this falls out. It comes down here to the C out n line, which takes you to the next line is 2. So starting with this number 2 right here. So n now becomes 2. You plug in 2 in this. Base is what? X is what? X is 1. I'm sorry, x is 1. X base is 2 raised to the 1. My apology. So this n becomes 2, right? And then 2 raised to the 1. I can't speak this way tonight. 2 raised to the 1 is 2, correct? And then you come over and you increment the n in this becomes 2, right? And 2 raised to the 2 is 4. Again, 4 is less than equals the 4 is less or equal to 4, so that's still true. You plug this in, 2 raised to the 3, right? Because you have to increment n with this, and 2 raised to 3 is 8. Okay, and then you go to 8. Basically, you increase this up to 16, and this continues. This loop continues 1, 2, 3, 4. Until what? Until your outer loop with this thing. Here's my body loop with this thing. When x becomes what? 10 less than or equal to 10. Again, this will always be 11, all right? But it doesn't, when x becomes 11, which it will never enter this block of code because of y? Because this will be true. Does that make sense? So that's why I want to talk to you about this, and we're going to go in and I'm going to do some problems with you in this next series with it as well.